Hi guys, my name is Vincent. I'm going to go ahead and explain how I did this problem. So first I analyzed case 1 and I inputted all the sales that would be happening throughout the months. So that would total out to 48,000. Did the same thing for case 2, but for the last 2 months it doubled, so I added 8,000 instead of 4,000. And that totaled out to 56,000. So to compute case 1, we first had to input the commission rates for each box, which would be 10%, 12%, and 15%. And since this is case 1 that we're focusing right now, we're going to go ahead and multiply the commission rates by the total amount of sales, which is 48,000. So if you compute that, it's going to come out to 4,800 for plan A, 5,760 for plan B, and 7,200 for plan C. And for the annual salary, I basically multiplied how much you would be earning per month to the amount of months. So that resulted in $24,480, $21,420, and $18,360 for the annual salary. And to compute the total, I went ahead and added the commissions and the salary. And if you look at the second case, I basically did the same thing, and plan A ended up being the most profitable. Thank you.
Hello everyone, my name is Brandon Villatuya. Today I will do a quick recap on two problems that I completed taken from our team project assignment. My teammates may have already covered or will cover the other three problems. The first of the two problems that I'm about to talk about is going to be the grass seed problem. So a man named John gets a new house. The lot that the house stands on is a rectangle that is 125 feet long and 77 feet deep. The house sits near the center of the lot and is 40 feet wide, 36 feet deep, and 2 stories high. John needs to plant his new lawn with grass seed. Each box of seed covers 500 square feet of ground. How many boxes of seed does he need to purchase? So, let's go ahead and think of a good game plan so we can proceed. My first course of action is to acknowledge my given information in the black font in range B10, C11. The question provides me with the width and length of both the lot and the house. So to calculate the area of the lot, I assigned the formula quote unquote equals B10 times C10 to cell D10. So let's take a look at cell D10. Okay, so B10 times C10 is assigned to D10. Okay, so the following D cells are going to be also assigned the same formula, only altered to match the correct row. So for example, the formula quote unquote equals B11 times C11 will be assigned to cell D11. The area of the lot, so the area of the lot came out to be 9,625 square feet. Okay. As depicted in green, while the area of the house came out to be 1,440 square feet, also in green. So before we can move on though, we need to make sure we keep note that each box of seed is 500 square feet. Okay? So next, I need to calculate the lawn area. This required me to find the width and the length of the lawn itself. To find the width, I assigned the formula quote unquote equals B10 minus B11 to cell B12. So let's take a look at B12. Okay, B10 minus B11 assigned to B12. Okay. And then to find the length, I assigned the formula quote unquote C10 minus C11 to cell C12. Okay, so right here. I found the lawn area by assigning the formula quote unquote D10 minus D11 to cell D12. So D12 right here, D10 minus D11 assigned to D12. Okay. This formula tells me that the lawn area is approximately 8,185 square feet. Okay, so the last step would be to use the information that we gathered to calculate the number of boxes of seed that John needs to purchase for his lawn. All we needed to do is divide cell D12 by cell D13 by assigning the formula D12 divided by D13 to cell D14. Okay? This tells us that John needs to purchase 16.37 boxes of seed, or in this case, approximately 17 boxes of seed thanks to the roundup function as seen above. Okay? So that's how many boxes of grass seed John needs to purchase. I'm going to move on to the next problem. The next problem that I will be talking about will be on compound interest. The question states that you have $1,000 to invest. You want to know how long it will take to describe excuse me. You want to know how long it will take to double your money. The amount of time it takes to double depends on the interest rate. A quick way to estimate the doubling time A quick way to estimate the doubling time is called the rule of 72. It works by dividing 0.72 by the interest rate. That tells you approximately how many periods it will take to double your money if interest is compounded. Compounding means interest is paid on both the principal and any interest earned up to that point. So it gets larger and larger every time. Simple interest, on the other hand, is when the interest is paid only on the principal. So it's more like a fixed amount. In each case that we're seeing, right, we observe what happens to $1 principal based on different interest rates coupled with the rule of 72. So the test factors and results are placed on range B15 through K18. More specifically, B17 through K17 required us to apply the rule of 72 to all cells in that particular range. When I assign, and then I assign the formula, quote unquote, equals B15 plus B16 raised to the power of B17 to the range B18 through K18. So that's the following range. This is the formula for ending value based on criteria like interest rate and the application of the rule of 72. We add the interest rate to the principal of $1, then we raise the sum to the power corresponding to the number of periods needed to double the money. In this case, we can see that the rule of 72 indeed doubles the principal up to about 6 to 7% interest, give or take. However, beyond 7%, the number of periods provided by the formula begins to fall short of doubling the principal by wider and wider margins. You can see right over here, it's starting to fall short once you reach 8% interest and onward. The margins become like larger and larger. Like the more interest you add, the more the formula seems to fall short of doubling. Okay, so this, if you look from B18 through A18 through, so B18 through K18, you'll notice more of a downtrend in the ending values as interest rates rise and as the number of compounding periods decreases. All right? So this concludes my recap of the grass and seed and compound interest problems. I appreciate you guys for listening, and sorry if I stuttered a few times, but we can only get better from here. Okay, I'll see you guys soon. Bye-bye.